Okay, this video is a continuation of our Zoom meeting we had earlier. And this was a homework question somebody asked me, and I said I'll just make a video later. So this is number 69 from section 6.1 on page 364, and it's about this airplane. And this is what it says. It says, find the measures of beta, which is this angle right here, B, beta, and C, this length C right here. If the extended leading and trailing edges, so this is the extended leading edge, and it's extended because this black mark right there is kind of where the wing actually ends. But if you extend it out into a space to see where these two parts would match, that's why it's called extended. This is the leading edge and this is the trailing edge. And so they said if the extended leading and trailing edges of the wing are 20.0 meters and 15.5 meters respectively, and the measure of the given angle is 35.3 degrees, find angle beta and find angle C. So if you look at this triangle that they gave us and what information they gave us a side, and an angle. And so we have the side angle case, which we can use law of sines, but this is the ambiguous case. And so we have to just be aware of that. Now, we don't have to find two triangles unless we have to find two triangles. When we look at this particular triangle, and you look at the shape of a wing, this part right here, this is not, this trailing edge, the angle that it makes with the trailing edge, is not acute, it is obtuse. And so we want to find this obtuse angle right there, not the acute one. And so you can know that just because that's how a wing is shaped. So this will be an obtuse angle, so we'll just take note of that. Beta is obtuse. All right, so here we go. We're going to use law of sines. We'll begin by finding beta. So we say the sine of beta is to the length across from it, 20.0 meters, as the sine of 35.3 degrees is to the length across from it, 15.5, and we can cross multiply and take the inverse sine, and then we can solve for what beta should be. And so I was doing this problem earlier, and I got a negative when I was trying to find the sine of beta, and I knew that that could not be right because the sine of 35.5 is in the quadrant 1, so I would only have positives. And the reason I was getting negative was because my calculator was in the radian mode, so make sure you're in the right mode. So when we do this, we will say 20 times the sine of 35.3 divided by 15.5 is 0.7456. We take the inverse sine of that, and it gives us that angle B, or beta, is 48.2 degrees. 48.2 degrees. Okay, now, this is an acute angle, but this one is obtuse. So this would be if we were solving for triangle 1. What we're going for is the second triangle where that angle is obtuse. So B2 would equal to 180 minus B1, which is 180 minus, the answer is 131.8. All right, and so right here is 131.8 degrees, and this is 35.3 degrees, and we're trying to find what C is, but we know this length is 15.5, and this is 20.0. Okay, so we found beta. This is what that angle is, and we know it was the obtuse one because that's the shape of an airplane wing. And so now we have to find this length C, so we'll use law of sines, and we can say little c is to the sine of this angle, so let's find that angle. 180 minus 131.8 minus 35.3, what does that give us? 180 minus 35.3 minus 131.8 is 12.9. over the sine of 12.9 is equal to, let's do 15.5 over the sine of 35.3 degrees. And we can cross multiply and solve for C. And when we do that, we will have 15.5 times the sine of 12.9 divided by the sine of 35.3 gives us 5.988 or 5.99 meters. Okay, so that's that one.